Okay, hi folks. I think we're bang on time here. I have a couple of slides to run through, so I think I'm going to start, yeah. Okay, I'm Christiaan. I'm a product manager at Google. I am mainly responsible for Google's foray into passwordless and passkeys and other things, but I also work with my cloud counterparts, and at Google, of course, we all work on deploying containers all the time. And that's what this presentation will be about. We're going to be talking a little bit about Google's BeyondProd implementation or concept. It's more of a concept than an implementation. In the same way that we have made public our BeyondCorp implementation, which is basically Google's implementation of Zero Trust, we're going to apply similar principles to talk a little bit about BeyondProd today. So here's a big question, right? How do you manage security when you have thousands of developers launching billions of containers a week with products that typically have more than 1 billion users? And you want to do that at scale, you want to do that repeatedly, and you want to do it consistently. So the issue is, of course, you have vulnerabilities, right? You have vulnerabilities in the common infrastructure. You have vulnerabilities in the software supply chain. We've seen many of those happen over the last couple of years. And then, of course, at the core of how CPUs work, like Rowhammer on the RAM side, Spectre and other issues on the CPU side. That's really what we're here to talk about. How do we minimize these risks? At the core of a zero trust approach is really the idea that implicit trust in any single component of a complex interconnected system can create significant security risks. And this is also the tenet, essentially, around Google's BeyondCorp approach here. So the foundation of zero trust really is centered around identity, policy, and dynamic context. And this can be applied to a diverse set of assets. It is independent of the network. Trust is evaluated per session and per resource. Policies need to be dynamic and context-aware, and evaluation should be continuous, not one time. So these foundations stem from Google's own experience, and you may be familiar, as I said, with Google's shift to BeyondCorp. BeyondCorp was a response to a change in the way that modern corporate users work. Today, users are mobile and commonly operate outside of an organization's traditional security perimeter, from a coffee shop or an airplane or anywhere in between. And with BeyondCorp, we went away from the idea of a privileged corporate network, and instead we grant access based on device context, right? User credentials, attributes, but it's regardless of where the user physically is. So then what's BeyondCorp? Well, it's Google's implementation of Zero Trust, and it's based on the principles that the traditional network perimeter need to be reimagined. It must not be determined by the network from which you connect. It's granted based on contextual factors, such as the user and their device. Is it a good corporate-owned device? Does the device meet the corporate policies, patch levels? And then, of course, it must be authenticated, authorized, and access should be encrypted. Now, some of you might be wondering, and this is what the pitch or the goal of this presentation is, how do we apply these principles in a new cloud-native world from a prod management perspective? Similar principles apply to managing prod. It's a natural evolution when parts of your production control plane are also now just cloud services. Cloud-native security addresses the same concern for services as it does for users. That in a cloud-native world, we can't simply rely anymore on a firewall to protect some perimeter, right? Because there is no perimeter. The idea is that production assets are running everywhere, typically and we'll talk a little bit about that, third-party data centers, like your own data center, might be running in serverless environments. And the question is, how do you actually apply these zero trust principles in a network or in a way where production is pretty much all over the place. So in the same way that users aren't all using the same physical location or devices, developers are not all deploying code to the same environment, and that's basically what the talk is about. So, of course, figuring out how to manage access here is a lot easier said than done. There can be a lot of challenges, and many of you are probably familiar with the common workforce challenges and how zero trust network access can be used to overcome them. Zero Trust has here at the event, I know there's a bunch of vendors talking about it, and just 2 weeks ago at RSA, literally every second, I think access control vendor is talking about Zero Trust and how you can apply it to your own environment. But there's many challenges in the workplace today, and today we're talking a little bit more about the actual the workloads, right? Not really about users' access to the workloads, but how do we authenticate workloads running in our environments if they're heterogeneous, right? They're all over the place. So, the challenges include typically the cloud-native architectures that we have, heterogeneous compute runtimes, ephemeral context, and then also, of course, enforcement, right? How do we enforce that the code that we're running is actually the code that we've built on our systems in a good environment? So as we talk a little bit more about the cloud-native world, I think everyone here understands these various concepts. There's really three things that we need to just, get the terminology right for. Containers, pretty sure everyone here is familiar with containers. Each workload is deployed as its own set of immutable, movable, schedulable containers. And the cool thing is they made individual machines much less important. Doesn't really matter where they're run. Everything is containerized, and we can lift and shift at any point in time and start it up in any new context. And then, of course, microservices is a service-oriented architecture that makes it easy to develop and debug different parts of an application. And lastly, continuous integration and continuous deployment. Standardized, automated build, test, packaging, and deployment that speeds up iteration and really helps improve reliability, because everything is built in exactly the same way by exactly the same system. Nothing is built on a user workstation anymore. We're centralizing all of our build processes. So the realization of this BeyondProd concept at Google required substantial changes over time in two main areas. The one is our infrastructure, and the other one is in our deployment processes. And more specifically, in a traditional security model, an organization's applications could depend on an external firewall, right? You provide the firewall around your data center to protect against incoming traffic, and you only allow in what you want to allow in. Now, in a cloud-native environment, although the network perimeter still needs to be protected, just as with BeyondCorp, right? You still have your perimeter, you still need to protect it. You can't simply rely only on this perimeter firewall anymore. This doesn't really introduce a new security problem, but rather recognizes the reality that a firewall can't fully protect the network. And then with zero trust, you can't implicitly just trust internal traffic. The fact that something originates from an IP address inside of your firewall is no longer good enough. We need other things as well, right? We need other controls like authentication, service-to-service authentication, and of course also encryption. So at the same time, the shift towards microservice provides an opportunity to rethink the whole traditional security model. As you remove your dependence on a single network perimeter, for example, the firewall, you can further segment the network by individual service. And to take this idea one step further, you could employ microservice level segmentation with no inherent trust between services. That's ultimately where we want to go. Really zero trust for our deployed runtimes. And then, traffic can have various levels of trust with different controls. You're no longer just having traffic is external, this traffic is internal. You actually have policies based on the individual services that you're running inside of these environments. So in a traditional security model, an organization's applications were deployed to specific machines, and they mapped to IP addresses, and then we could establish trust based on certain IPs using firewalls. These IP addresses also changed very infrequently. Static IPs was a thing. We could match a particular service to a particular IP address, and that meant that the security tools that we deployed could rely on this mapping, right? It's kind of like mostly a static mapping, and firewalls really was one of the ways in which we essentially set the policies to control access between these different services. Now, in the cloud-native world with shared hosts, more than one service running on the same host, and then frequently changing jobs, using a firewall to control access to microservices doesn't really make sense anymore. You can't, rely on the fact that one IP matches to one service exactly. So we need to really base things on more than just an IP address or a host name. We really need to base identity on a service. So to kind of get to that point, perimeter-based security, right? In the next slide, there we go. Talk about this, perimeter-based security, right? On the one side, traditional, we've got a firewall, internal communications considered trusted, simple IP whitelisting, moving that to a zero-trust world where we have service-to-service communication verified. And we'll talk in a couple of slides here exactly how we do it at Google, how is that authentication established. Again, on the traditional side, security requirements built into each applications and enforced separately. The idea here is that we move to a world where shared requirements like TLS, authentication, and authorization policy is integrated into service stacks with centralized policy management. And really what that means is the developer isn't responsible for that anymore. It's handled separately from the actual service or the actual deployment. So it's centralized in a way where we can have policy in one single place and then kind of like uniformly apply it everywhere. Specialized and infrequent rollouts, we kind of used to do this. Someone would build something on a particular machine or on a server somewhere and then deploy, and if that person is off sick, the deployments don't happen. Maybe next week, hopefully they continue. We move to a world where standardized build and rollout processes, is basically, individual services are built in a way where it's continuously deployed and continuously tested. And this makes it much easier to review and ensure software supply chain integrity. If there is an issue in an upstream library that you're using and we really need to urgently patch, that can be done by anyone. It gets pulled in, gets built, gets tested, and it gets auto-deployed. And we're not relying on a single person who's responsible for that code in order to build that in a way that, with all of the quirks and all of the right libraries, and then, deploy it to production. And then unit of isolation was typically, a physical machine or maybe a virtual machine in later days. But nowadays, we're bin-packed workloads running shared operating systems. And what we really need there is we require strong, individual sandbox isolation. We can't rely anymore on the fact that things are running on separate physical machines. The same service or different services can actually be run on the exact same machine and on the exact underlying hardware. So we really need to be cognizant of the issues that can introduce. Click. There we go. So here really is the essentially, distilling what I've said in the previous slide down to the actual principles and what we do to deploy this. So before BeyondProd, things were based on IP addresses, as I've said. We've moved to a world where things are now based on service-based identities. Security-specific requirements built into each application and enforced separately. No, we move to a world where we're sharing security requirements and it's integrated directly into a service stack with centralized policy enforcement. Limited restrictions on how services are built and reviewed, move to a world where security requirements are applied consistently in one single build system, and then we had limited oversight of security components. No, what we want is a centralized view of security policies and adherence to these various policies. So at the core of a zero-trust approach to security is the idea that trust needs to be established via multiple mechanisms, and it needs to be continuously verified. So first, let's talk about what we mean when we say a workload. Now, this could be an app, or like a SaaS app, a device, IoT, device, or computing device, or IoT device. Really, anything that can run a task somewhere is considered a workload. And consider a cloud-native architecture where apps are broken into various microservices. We have the service mesh that needs to provide service identities. It needs to provide the pure authentication between these different services. Encryption of communication needs to be done, and also the authentication and authorization of this service-to-service communication, because we're no longer using IP addresses. And this equally applies to any endpoint, like whether you're talking to IoT devices or other computing devices on the network. We really have to do this everywhere. Now, how does this work in a zero-trust world? And this is a bit of a generic representation, but first, we need the workload to get some identity. And this identity normally comes from like some identity provider, a couple of the larger identity providers on there. And then in the next slide, we'll kind of look at how this actually works. Like once you have this identity token and the workload has an identity token from one of these services, what happens next? So the component of a zero-trust credential system really is that we have a highly scalable credential issuer, some certificate authority. We have some identity and federation management control plane, and then we have a managed credential, which includes like a lifecycle manager, because we need to rotate these things all the time, and we need automatic distribution of these configurations in our environment. So let's take a look at how this actually works. And typically, identities in this space is issued. We have the authentication token that gets issued in the previous slide, but what we essentially want is we want these workloads to have some form of identity, which is normally an X509 certificate, and then the question is like, how do we get there? How do we get from this identity token that we've got down to an actual X509 certificate with a private key that is then used for mutual TLS in our environment? That's really how we do service-to-service authentication. It's all based on MTLS. So first we start with the workload getting an identity on the control plane. So there's a registration step. There we go. And we get some configuration back. And once it registers, it receives this configuration on how to get the credential from the cloud, like where should it go next to get its certificate. So it exchanges the identity token, as we said earlier, that we got from the third-party identity provider. It then goes ahead and exchanges this identity token for, there we go, a federated identity token, and once it has the federated identity token, it can now go and it can request a mutual TLS certificate from the system, from the CA, the certificate authority, which is then ultimately used to authenticate this service on the network. And we use SPIFFE for that. So once we have all of that in the next, let's we go, Now we have an identity for every service. Every service gets a configuration from the system, from a configuration manager. It then knows where to go to get its certificate. It exchanges the identity token for a cert, and once it has a certificate, now it can actually start to perform actions. Now it can start to call other services, and authentication happens based on pure MTLS. The problem is this isn't always super easy. Although we're using well-defined constructs and components, that is like CAs, IAM essentially to set the policy, all these things are there, but deploying this is kind of hard, right? Building at-scale federation systems is challenging. Building an at-scale private certificate authority to issue these identities, they're hard. Building at-scale credential lifecycle management systems, hard, because if your certs expire, you have an outage, right? So there's a lot of things here that gets added on top of the traditional burden of running systems at scale. And then, building at-scale config management is also hard because the target platforms might differ, right? You might have things deployed in Linux here and maybe BSD there or Mac here. Getting a system that can do heterogeneous config management is fairly tricky. At Google, we try and keep things uniform as much as we can, but we realize that that's not always an option for everyone out there. And then lastly, integrating the credential system with cloud provider or native credential system is also hard. Depending on who you're working with, it might be easier or harder to do these various plugins. So given all these challenges, here's our advice. Focus on where you are today, start with one area, and then build from there. So Google's transition to cloud native required changes in two main areas: infrastructure and our development processes, as we said earlier. So we tackled these two changes simultaneously in our environment, but they could be decoupled and addressed independently. All too often, security is kind of called in last, when the decision to migrate to a new architecture has already been made. By involving your security team earlier in the process and focusing on the benefits of a new security model, like simpler patch management, tighter access controls, a cloud-native environment can really help provide significant benefits to both application development and to your security teams. When applying the security principles outlined in the paper that I'll link to in the next slide here, you can strengthen the deployment of your workloads, secure their communications, and really limit their exposure to other workloads as well, which is critically important in this containerized world that we live in. This reduces reliance on individual developers to get security right, which really is a win-win for everyone. So it might be a little bit harder to get there initially, but then going forward, the reliance on the individual developers is significantly lessened. So let's do a quick recap of the tenets of BeyondProd. If we develop cloud-native architecture, we want to concurrently strengthen our security, and so we developed and optimized for the following security principles. Protection of the network at the edge, still doing that, probably still have firewalls and other things in place, but also beyond. Also, inter-service communication is protected. There is no inherent mutual trust between services. Trusted machines running code with known provenance. We have these control points or choke points for consistent policy enforcement across services. Simple, automated, and standardized change rollouts. So when there's an issue in some upstream library, it should be trivial for anyone that recognizes it and realizes that to rebuild and redeploy in a completely automated and repeatable fashion. And then we want isolation, of course, between different workloads. I realize that this is kind of mainly a talk about the concepts. If you want to get down into how we do this at Google and what capabilities are available, feel free to look at the BeyondProd white paper, our application layer transport security white paper, and then we get a little bit deeper into the weeds with binary authorization for Borg white paper, how we deploy trustable code on different in different environments, and then also in the security infrastructure design white paper. Thanks, folks.